In this video, we're going to do another practice on how to create interval estimates for the population proportion. We're going to use data file LawSuit. So here I have the data file LawSuit, and we're looking for 99% confidence interval for population or US proportion of medical doctors who have been sued by a patient in their career. So this is what we're looking for. 99% confidence interval for population proportion of medical doctors who have been sued by a patient. So now, again, what we're looking for is going to be basically the proportion, sample proportion. For sample proportion, we need size, we need responsive interest. That would make it easier to basically track it. Responsive interest, and then count of interest. In this case, responsive interest would be yes, all those doctors who have been sued by a patient. All right, and then, so size would be count A of my whole sample, or you can simply put 150 if you know the size. Response of interest is yes, so I'm gonna be counting, count if, in column A, if how the number of yeses, basically. That's what I'm doing here. So formula, and so that's the response of interest. This is the count of interest, and now I can find the sample proportion, or P bar. So P bar is out of 150, 92 people, 92 doctors said they've been sued by a patient in, let's say, or maybe from the beginning of their career, or maybe in the past 10 years, depending on the case, depending on the sample. So now we have the sample proportion. We are looking for, now we need to build the margin of error. For margin of error, I need the confidence, I need the Z value. For Z value, I need the confidence coefficient, which gives me the level of significance. And with that, I can find the Z value for half of alpha, for half of level of significance. When I have this, I can also find the standard error. And with Z value and standard error, I can go ahead and find margin of error. And with that, I can find the point estimate, upper limit, and lower limit. So confidence coefficient is given to us 99%. In exam questions, we are going to be given with the confidence coefficient. Even in practice, there are usually conventional set of numbers that people are using, like 90%, 95%, or 99%. These are most customary numbers. So confidence coefficient 99, level of significance always is going to be 1 minus confidence coefficient. Z value is going to be norm dot S dot inverse of probability for Z value is going to be 1 minus half of alpha. Right? So because we're looking for Z half of alpha. If you put half of alpha, it's going to give you the negative of this number. If you put 1 minus half of alpha, it gives you the positive, right? The same number, but positive. So now we have the z value. We need to find the standard error. Standard error is square root of p bar times 1 minus p bar in parentheses divided by sample size. And that would be the standard error. That would be the standard error. Margin of error now would be z value times standard error. All right, so the multiplication of z value and margin of error. And now that I have margin of error and the sample proportion, I can go ahead and find the interval. The center of the interval or point estimate would be simply the sample proportion. Upper limit is going to be point estimate plus margin of error. Lower limit is going to be point estimate minus margin of error. So this is basically how we build a 1 minus alpha % confidence interval for population proportion. And I can, again, go ahead and write that with 99% confidence, proportion of doctors who have been sued by their patient should be between 51 and 71 or 72%. So it's 51% and 72 almost. If you round it, you get 72%.